Okay. do do do. Let's put a countdown. SH no Bork AFK stream starting. Nokodoko. Hello, what's up? I'm starting the stream. We're doing some Zig. So if you are into the Zig programming language, you might enjoy the stream. If you're not into the Zig programming language, but you are into lower level programming, which is it's kind of a misnomer. Like calling it lower level programming, it's kind of a dumb choice that our industry made. But well, that's what people say. And yeah, so that's the type of stuff that we're doing. Oh, you're so curious. Nice. Nice. Okay, so the plan for today is to make a small improvement to some of the projects that I work on, like my main projects, mainly the static site generator. But it has like an ecosystem around it, and I want to make improvements in it, a bit at a time, and then I'm gonna continue the work that I was doing with trying to see if we can make a better flexible array style thing in Zig and see how that lends itself to Radix 3. Let's say I programmed in Go, Python, and Lua for a while and doubled with Rust for a little bit. Cool. Nice. Hello, ByteFox. Okay, so you know what? Let me go get something to drink, and then I'm gonna start. So Okay, I'm back. Hello, Blurry Cat. Okay, let's get started. So here's the plan. I mentioned it earlier, but for the new people that joined, the plan is the following. I want to make one small improvement to the Zine ecosystem so that we move some things forward just by a little bit. And then we're going to continue with the main thing that I'm looking to do right now, which is test the flexible array thing on a Radix implementation and see how that goes. Also, this whole discussion was started here from Tristan Pemble, who made he called them resizable structs and then renamed, I believe, this stuff to structured slice, which is also not a bad way of calling it. In any case, he also proposed his own version of what I'm working on, and his version puts everything under a tail struct. So it collects stuff on the tail. Why am I lagging? What's happening on this computer? Nothing should be happening. What's going on? In any case, what they're saying to do, yeah. So he puts everything under a tail, and then each one of these things, and then every field is still tail slice. I call it flexible array, but the idea is roughly the same. And let's see what he does. So in the main struct, okay, this is still the approach where there is no reified fields, I believe, because we're returning a struct that has no fields. You can see it here. It has something that says is tail, which is just a void value. Then and he does validation. And it checks that there are no multiple tails on a struct there. Then before we look at the methods that this thing exposes, let's take a look at the individual tail slices. So tail slice only contains decals. And this is a len field is field. This is an enum literal. So how does he make one of these guys? The answer is mostly manually, and then he has tail copy. Yeah, which is my approach, basically. Okay, let's take a look at this stuff. So let's look at our main implementation. I think I had a good things going on for me. That was fine. That was nice. We're missing alignment information, so maybe we can add alignment, and then we need to implement resize. Although I am really tempted to implement a non-linear resize. But that requires usage of null terminators necessarily. Oh, okay. So here we have slice. Everything looks good. I think this can be an enum literal. Then we have slice of a field. That's nice. We have init. Then we need maybe set individual value. Although we don't really care because we have slice. So slice gives you this. And so, yeah, that makes sense. Donho, hello. Thank you for the raid. Welcome, raiders. Hello, hello. Let me give you a quick recap of what we're doing. So, actually, why am I looking into this? I was supposed to do this first. I don't know why I went immediately here. In any case, so here's what's happening. Here's what this stream is, or this channel is more in general. I do stuff with Zig. I work at the Zig Software Foundation, and I have a bunch of projects that use Zig, and well, I have to maintain them, and so I do that on stream usually, and I experiment with Zig stuff. So here I have two things on my plate for today. One is I have a static site generator written in Zig called Zine, and I want to improve the ecosystem, but there's a lot of work to do. I decided to make Zine a kind of complicated project, and it's only me, well, mostly me doing the work. So there's a lot of the ecosystem that needs improvement. Specifically, this has to do with how the templating language works, and I want to make improvements to the templating language bit by bit. And the second thing that I'm looking at is taking a Radix 3 library written in C and port that to Zig, but also try to do that with improved ergonomics using just a little bit of Zig metaprogramming called ComTime. This the second thing is related to this recent discussion where here you can see Tristan Pemble has made a blog post and a repo where he implements a thing that he ended up calling a, or at least that for now he's calling a structured slice, where the idea is that you want to have an allocation memory that has variable length, but you also want it to be one contiguous allocation. If you don't know anything about memory management, this is a thing that, like, this doesn't mean anything to you, because usually in higher level programming languages, you don't get to decide what is the memory layout, and you get whatever the higher level programming language gives you, and you better like it. But in lower level programming languages, you decide exactly how the bytes are stored in memory, and that has a gigantic impact on the behavior of your program. I guess the most obvious thing is performance, but it's not just that. It's also like how memory hungry it is, how it can fail or not fail to, allocate resources, and then what happens when that happens. Programs don't have necessarily to crash if you run out of memory, for example. Most of them do. I mean, if you make a Python program, the only thing it can do is crash. Same with JavaScript. But for other languages, it doesn't have to be this way. In any case, so there's like this discussion on how to implement this pattern in Zig, and And so that's what I want to take part to, or participate in, whichever way you want to say it. Okay, so let me exit from this and let me actually follow my schedule. So I want to go to Scripty, and I want to give to it a parser. Hey, nickname that. Just switch to Twitch to watch an ad. Nice. I hope you enjoyed the ad. Resource. So let's see what we have here. We have some fuzzing stuff. Even Java can handle I imagine that it can in some ways, but how does that work? Is this like at the VM level? Because I think that this, if I remember correctly, in Java, it's not like new can fail to make a new instance of an object. It's expected, like it doesn't have error handling attached to it. Although I guess it could throw an exception, but does it throw exceptions? An exception if it's out of memory? I think not. Also because to throw an exception when it runs out of memory, it needs to allocate the exception. There's an exception for out of memory. Interesting. But don't exceptions also require memory? Well, anyway. So here we have the tokenizer. We have the old tokenizer, which I'm still keeping around. You know what? Move source / tokenizer old to tokenizer reference. Okay, so we have this. Then we have a parser. But here's the problem. The parser doesn't build a tree. It just gives you one node after the other. Because it's designed to work in conjunction with a stack-based VM. And I guess maybe this is fine. Maybe this is not necessarily wrong. Maybe so. I guess my point is that we don't necessarily need to change this. Although, notice something. This is a while loop, and this is a switch. What does that smell like? To me, this smells like that this should be rewritten using label switches. And like I'm semi joking, but like the answer is yeah. This should absolutely be rewritten to be based on label switches. The problem is that this logic is convoluted and it's easy to get wrong. And it's easy to get wrong. And I don't want to touch this now because I'm going to break it. And the problem is this. With the tokenizer, it was easy to test the new tokenizer and make sure that it just worked correctly. This one is harder because I don't think my test suite really covers it. I have some tests, but as you can see, I don't have a ton of tests. I have basics do to method chain, dot after call, that kind of stuff. So I have some, the main things that used to be broken in the past, but I don't have like extensive unit testing. And in any case, this is fine because what we want is actually for this to be really fast more than anything else. So, oh yeah, it's my code. Yeah. It was me keeping around the other copy of the tokenizer because it's useful for fuzzing. The idea with fuzzing is that one way to, like, the basic way of fuzzing your code is that you fuzz against your assets. So you have a bunch of assets and you fuzz, and your goal is to, well, see if you can trip any assert. If you can trip it, then your assertion is wrong. It means that you assume something that isn't actually true. And so either that assert has to go and you need to handle another condition in that part of the code, or that assert is actually real and correct, and somebody up the call stack did not uphold that invariant. So, or precondition, like whatever the assert is, like somebody didn't uphold that. And so some other piece of code needs to be fixed. That's one way of doing fuzzing. And it's good. It's absolutely good. But there's a better way of doing fuzzing where you do this, and on top of that, you also have a oracle. The oracle is another implementation of your code that you trust. And then what you do is not only you fuzz trying to leverage assertions, but you also try at the same time to, after you're done running, you compare the result for the same input on the two different implementations, and you check that it always matches. If you find a mismatch, then you found a situation where your new implementation behaves differently than the old implementation. And so that's another like extra layer of fuzzing that is delicious to have. The problem is that right now I don't have a fuzzing setup. AFL has regressed horribly. It's bit rotten. LLVM has broken it in so many ways. So it's pure crap right now. We need Zig's native fuzzing. Like, this is really IO and fuzzing right now. I feel like are the two big bottlenecks in the Zig ecosystem. Once these two are solved, really sky's the limit. And once we have async, Go will need to go on a diet because there's not going to be as much food in its lunch as there was before. Well, but the thing is that fuzzing code guided fuzzing doesn't have to be integrated with LLVM. It's something that can be also implemented elsewhere. It is actually, some of it is implemented also in Zig natively. Just not all of it, not enough. And so right now, everything depends on LLVM to do some stuff, but it doesn't have to be. So when it comes to fuzzing specifically, we can just replace LLVM, not by, making our own LLVM, but just by taking away this duty from it. So we can do it. That said, maybe in the future, the plan is to switch away from LLVM. That's for sure. Okay, so what is this parser then? This parser maybe is not that bad because it's giving us nodes. It's giving us path, call, apply, true, false, string, number, syntax error. Okay, so it's giving us these nodes, and we're receiving them in a linear fashion, and that's actually fine. That's actually fine. And if we really wanted to build an AST out of this work, we could do it. So we could create an AST file and use that to create an actual, basically, like graph of these guys. The question is, should we? Should we do this? And it is a good question indeed. Should we? Should we do this? What do we gain from this? So let me rethink about my end goal. My end goal here is this. I want to be able to implement a scripted linter, for example. So the ability to check for scripted expressions inside of super HTML, for example, or inside of super MD. Right now, we literally do not care about any of this stuff at the LSP level. Well, SuperMD does not have an LSP at all. SuperMD does not have an LSP at all. So SuperMD does nothing with this because there's no LSP, period. And that is, I guess, fine. And we should have one. But for now, I guess the most straightforward improvement would be getting this validation working in the Super HTML LSP. Which means parsing a template in Super HTML and then being able to obtain from the AST all the locations where there's a scripty expression, which we do because the Super HTML AST keeps track of scripted expressions. They are, well, basically, not entirely, but mostly the nodes in a Super HTML AST are nodes that contain scripted attributes. And so what we want to do is go over those and validate that everything tokenizes and parses correctly. And then if something does not parse correctly or does not tokenize correctly, then we complain. And I believe that this guy does, even though it builds one node at a time and it doesn't really build a data structure in memory, I believe that this guy has enough context to let us know. So for example, something like there's a dot, let's see, there's a global, let's see, we're at the start and there is no $. So the fact that there is no $, becomes a syntax error. What does a syntax error mean for us? So we return p.syntax error. What's a syntax error? It's a node that just says syntax error at this location. It doesn't have an explanation why this is a syntax error. Okay. So one improvement that we could make is say, well, let's provide also information about what syntax error is that we're looking at. So I think we can do it like this. We look at node. It has a tag. It has a location. You know what? Okay. So what I was thinking how to do this. I guess I could add another field in here that is only used for error cases, but it's kind of wasteful. Another way of doing it is to beef this up because, for example, not starting with $1 is a syntax error, and this could be like, for example, well, it's not actually here. It's more like here. That would be syntax missing $. And so this says this is the state where this is the enum that says, oh, it's missing a $sign. And so elsewhere we map this to a nice error message that says script expressions must start with a $sign. So we could do this. Maybe this is what we should do. I mean, we don't even have that many tags. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I mean, we need 256 before we fill even a single byte, so might as well. So let's change this. And then we need a set of error tags. You know how you can do this also? There's another trick. You basically do this. You say it's an error if the enum value is equals or greater than this. That also works. And for convenience, like you can make it like a convenience method that says is error. So let's do this. Missing $. What else is there? And now syntax error requires you to pass in the enum. So error needs to be a tokenizer token dot. No, this is wrong. This is the parser. So this is a no dot tag. this it? Yeah, it's a node.tag. And yeah, tag is error. And we assert here. We assert that error enum int from enum error is greater or equal to node.tag dot syntax. Maybe we can do it like this: error underscore syntax, error underscore missing dollar, or this could be error token. Yeah, look, here's how we do it. Hey, Roy, let's go second raid. Hello, everybody. Hello. Welcome to a high octane, high intensity parser refactoring stream plus Radix 3. So I'm taking a moment to do some minor refactoring to a parser that I have to improve my static site generator ecosystem. Tiny piece of work that should be done, I don't know, like in half an hour. And then we're gonna port a C library that implements a Radix tree, and we're gonna port it to Zig. I've done this already in the past. It's been a while, so I won't remember necessarily everything by heart. But the goal is to use new metaprogramming features in Zig, or rather, it's not features in the language itself, but it's a new abstraction that I've been cooking with the help of Andrew. Andrew actually started the original design, and then we've been tweaking it. This all based on a discussion that's happening in the ecosystem right now about this general type of data structure, and we're going to use this to see if we can port the C library in Zig, make it as good. So the point is, it has to be at least as good. We have to lose nothing and only gain, and we try to see if it works. And that also is going to be something that will allow me to, I don't know, learn stuff and then tweak the implementation based on what I learn. Or maybe we'll conclude that actually we can't. Maybe we'll conclude that turns out that actually Zig is useless. Should have learned C all along, and life would have been better. Who knows? We'll see. So right now, here's what I'm doing. I have a tiny. Actually, I can explain this in concrete terms. Should have learned Odin. No, thank you. So here's how it works. In docs here, you can see that, let me see where I can show this. Scripty basics, I think it's fine. So I have a templating language that works like this. Never mind the kind of borked syntax highlighting. That's something also that we'll need to look into. But we have an HTML templating language that accepts expressions in special attributes. And these expressions start always with a $sign, and they are like very simple. They only support like, navigating fields with a dot, calling functions, passing in string literals, booleans, numbers, etc. So very simple. Here's the problem. The LSP for this templating language, which by the way also works with vanilla HTML. So if you ever wanted a vanilla HTML language server, do check it out. It's called Super HTML. You can find it also in the Visual Studio Marketplace. Just search Super HTML, open an HTML file, write, for example, close a div tag that you never opened, which is obviously an error, and you will see squiggle lines. And you're welcome. Apparently, VS Code couldn't do this on its own. So but in this case, I'm not working on features for vanilla HTML, but I'm working on features for my templating language specifically, which is a superset of HTML basically, because it's valid HTML, but $ stuff has a special meaning, roughly speaking. So here's what I want. I want that language server to be able to parse these bad boys and tell you when there's a syntax error. That's what I want, basically. Rust would be a better fit for this task. Which task? The Radix tree from C? I actually would say that this is the opposite of correct. Parsing better than Zig. Why? I would say that that is also wrong. So here's a question: Can you make these bad boys? What are they called? DAF machine, DAF device. Can you make DAF devices with Rust with the switch statements? If you can, then I think that a parser in Rust doesn't miss out on anything. Type system, pattern matching, etc. What has any of this stuff to do with a parser, though? Let me tell you what is interesting in a parser. Two things are interesting in a parser, which the Rust ecosystem, generally speaking, doesn't get right. Number one, and you know what? Let's move away from this parser because that one is kind of wonky. Let's go into Super HTML. This is an actual HTML parser. So check this out. First of all, tokenizer. Oh, you know what? No, the tokenizer, I will show you the scripty one, and then we'll switch to HTML for the parsing. So here's what you can do in Zig when you're creating a tokenizer. You have this thing which is called a label switch. So the idea is when you do a switch, let me show you maybe what the old version of this was, which is normally what you would do in most languages. So in most languages, you have something like this. You have a while loop, which could be while through, and then you increment, and then you have an exit condition inside, or it could be, while the index is not at the end of the string. So you have some minor variations here. But the idea is you look at a byte at a time, you switch over the state of the tokenizer, and the tokenizer is thinking, am I looking at an identifier? Am I looking at a number? Am I looking at a string? And so these are the states that the tokenizer can be in while it scans bytes. And then, based on what you see, you modify the state, and then you loop again. So you fall at the end of the switch, and then you have a new loop in the while loop. And this is fine. But what does this end up looking like? This usually ends up looking like that you switch, you modify the state of the tokenizer, and then maybe you modify the character that you're looking at because you are incrementing the index. And every time you return to the while loop and then you switch again, you're basically like reevaluating what the state is, and you're reevaluating what the character is, and you're branching again on these values. What you would want to do, and what a DAF device is instead that sometimes, for example, look at it here. I know that here the state needs to be .identifier. Why am I not just able to say something like this? Go to, I don't know, switch. This is magic syntax that makes no sense. But what if I could say go to switch.identifier? Meaning I want here to immediately continue evaluating this stuff from this block, in this block. Like I want to jump into this block and continue without having to have the full loop and everything else. Never mind that in this case, we also have these side effects that we are relying on. So let's assume these are not here. You would want sometimes to be able to do this. But when you have a while through and a switch, this is not what you're saying. Can an optimizer optimize this into, can you not say break label? break to label. It would be continue to label more than break, because break, generally speaking, means like stop doing what you're doing. And the answer is yes, you can do that in Zig. But my point is, when you express a tokenizer this way, maybe the optimizer is able to understand what's going on and turn this into something optimal, but it's not guaranteed. And oftentimes it can't. Also, you just cannot rely on the optimizer and never, because the optimizer, like LLVM specifically, it's full of bugs and regressions. Every time they make a new one, stuff that used to work doesn't work anymore. It's a mess. So what you would like is to have more expressive power to basically guarantee that once you get here, it's always an immediate jump without having to redo all this work. Okay, so this is my new tokenizer, which uses labeled switches. So labeled switches can do this. And the idea is literally this. When I see identifier, I continue state identifier. Notice that I don't have a while loop anymore. There is no while looping anymore. It's the switch itself that kind of acts as a loop, because we continue on this label. And the idea is like this. We start the switch by passing in the start state. And then every time we continue, we pass in what is the new state, the new argument to the switch going to be. So here, continue state identifier conceptually means this. We want to jump to this label and then assume that the value here is identifier. And so we switch to that identifier. In practice, this is not what happens. What happens is that this is literally a, please just jump immediately into that block. You can also pass in runtime values. So if the value is hard-coded in the source code, it's comp time known, then obviously it's an immediate jump. If you pass in a runtime value, then that does need to be reevaluated, of course, because it's a runtime known value, and so some decision-making, some branching on it needs to happen. But still, this helps the compiler emit much more efficient code. And this is usually what gets called a DAF device. Specifically, I think DAF device is how to pull this general idea off in C with much worse tools given to you by the language. Now, what is the difference between this and what I showed you earlier? And the answer is that we can actually take a look. Did I break anything? No. Okay, so this guy is fine. This guy added a new line. So I added a benchmark here at the end where I try to tokenize for 1,000,000 times this expression. And the other one, the reference, has the same main function at the end. So what I do is this. I do, let's ignore for a moment the parser. So I go into source and I do zig build xz tokenizer, and I'm going to call it, let's call it label. And then we have tokenizer reference, which is the old version. And I'm going to call it while. So we're basically we're comparing having label switch versus a while loop. And then we can do hyperfine while labels. See what it says. Oh, also got it wrong. Never mind. I forgot one thing. We obviously want to make an optimized build. We need to make an optimized release. Otherwise, the comparison, I mean, it's not completely meaningless because it shows you the difference in performance between non-optimized builds, but still, you want to see what happens after all the optimizations kick in. The answer is that the one with labels is 63% faster than the one with a while. This is not insignificant. I also have poop working. We need sudo. Can I find the code on GitHub of what? Of Zig itself? Yes. Of my stuff? Sure. It's called Scripty on my GitHub account. How can I debug Zig? With a debugger. I don't know, GDB, LLDB, whatever bugger you like, the bugger you like, it works. So check this out. The performance difference is, I think, interesting. So according to Poop, 34% improvement. So compared to Hyperfine, this seems slightly different, but still big improvement. And you can see that everything else improves. Why is it faster? Because it needs fewer instructions and it needs fewer CPU cycles. It does less work. And so it also has fewer cache misses and fewer branch missings because there's fewer branching. Because some things that previously were branching now that maybe that had to be predicted, and maybe the CPU was predicting mostly correctly, but not every single time. A bunch of these things are now just not branches at all that don't need to be predicted. Yeah, my stuff is here. What would you do in C? Good question. Can I see? You do something like this, I guess. Let's see. Let's see if there's a better way. Register, and they're using a keyword called register. What is going on? No, register is a type that they made. Honestly, I have no idea. Just look for for Duff's device, and I guess you go spelunking in a bit of history of the history of this stuff, but it's I don't know. It's weirdo stuff. Unnecessarily complex. So and so this is big. And by the way, this same result that I showed you in my silly project, check this out also in Zig itself. Zigland.org devlog archive 2024. Check this out. Zig tokenizer updated to use labels with statements. For Zig, it yielded a let's see. Updated Zig tokenizer to the new syntax, measuring a 13% wall-time performance increase for the Zig AST check command. So let me explain why this number is different than mine. This is testing basically the Zig auto formatter. It's testing the Zig auto formatting tool, which doesn't do just tokenizing. It does tokenizing, parsing, and then it validates the AST and provides transformations when re-rendering the AST because it's the auto formatter. So in this whole thing, tokenizing is just a section of it. While in my benchmark, I was testing pure tokenizing versus pure tokenizing, and I was stopping there. I wasn't going into parsing or any other thing. So basically, in my case, we were looking at almost like through a lens, specifically on the changes in tokenizing. Here, tokenizing was always a minor part of the entire process, but still, it still resulted in some improvements. So, long story short, Zig has some pretty good ass features when it comes to writing pure parsers. And actually, I just showed you tokenizing. Then there's parsers. Here's a couple of things that the Rust ecosystem doesn't do right. When you make a parser, you can create you can use pointers and you can create like an actual graph of nodes, like a tree, I guess, of nodes. And you navigate from pointer to pointer, and each one of those is a separate memory allocation. And then I've seen some people that were trying to make this better, where they would use an arena allocator so that they would still have individual allocations, but they would live inside the same memory arena, which you could free all at once. And which also would be more performant when creating single allocations. That is kind of cool, but you know what's better? When your entire AST is not this. So let me go to the to AST. What is nice is when your AST works like this. Nodes you make a contiguous, you put them into an array list, and you don't use pointers to connect a node to its children, but instead you use indices. You say you use well, let me see how I know this defined in here. You see here I have parent index is the slot in the array where the parent node is. First child, the node in the array, the slot in the array where the first child is. And actually these are kind of redundant because you can even get rid of these and only keep around child count. Just like replace these three indices with just one counter, and you actually have pretty much the same information. The point is, this also makes great performance differences, and people in Rust don't do this. Finally, here's my final thing to bring to attention. Check this out. Not my music. Check these out. Check this out, this talk from Andrew, where he explained another technique that I'm currently not using that I want to check out, where he explains how to use data-oriented design to make a parser even faster. People in Rust don't do this much. Hopefully you guys have some libraries that provide this, but I've seen way too many people just not know at all about this stuff. So, long story short, I disagree that Rust would be a better language to do this stuff in than Zig. It would be a perfectly fine language, absolutely legitimate choice. And if Rust is what you're comfortable with, and you want to make this type of tooling, it works. You're gonna be able to make something good. You need to put in some with elbow, and sometimes you will need to go against what I suspect the Rust ecosystem considers idiomatic and the right way of doing things, because if you want to make it really performant. But no, it's not a better language than Zig to do this kind of stuff. What is the challenge? I don't know. Here's the challenge. Make a parser, make a tokenizer for my language, for Scripty, that in Rust, that does the exact same thing that my tokenizer does, and race them and see which one is faster. If you can make a faster one than I have, great. You have, I don't know, won the challenge. Not to say that it is impossible, by the way. You can. You just need to put in effort. Probably more effort than I had to put into my tokenizer. They would both be memory bound. I don't know, man. I just showed you two different implementations of my same tokenizer, and there is a non-insignificant difference in performance. So I don't know. But you know what? Maybe they are network bound or something. Who knows? What is that command? Poop? Poop is Zig's hyperfine. And roughly the same idea, but it gives you information about peak memory usage, CPU cycles, instructions, cache misses, branch misses. I think the Linux version gives you also more even more information. Okay, let me go back to actually doing something useful. So parser, what we were doing is in the parser, we now want to have proper errors. Have a nice day. So the int from enum has to be equals or greater than int from enum tag dot r token. Okay, there we go. So we have is error. And so what we can say in syntax error, we can say, you need to give me an error tag, and then we assert that is an error. I cannot believe that I don't have asserts in here. I should have asserts, more asserts. I don't know. Maybe not. This wait, this is the parser. Yeah, I should totally have asserts. God damn it. What does int from enum even return? The enum value. Enums are basically numbers. Like an enum is a number where you give names to specific values. So you can take an enum. This is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. And yeah, and for convenience, you want to refer to them with names, but they have values and they have a sorting order. And you can say that you can assert a property of these values. I could have like a switch where I say, yeah, this one and this one and this one are considered errors, but I can also do this and have this convention that from this value downwards, everything has to be an error, which makes sense because I mean I don't have any other type of nodes in the language, so. So error missing dollar. Let's see. Okay, now we need to basically look at all syntax error, all calls to syntax error, and we need to say what is the error. We need to be more precise. So here we say missing dollar. So this is .r missing dollar. Then let's see. This is another syntax error. What's happening? We have seen the dollar sign. We're looking for an identifier token, but we get a token that is not an identifier. Switching line else starts with R. I think that would not easily turn into optimized code, though. If you think about it in terms of like machine operations, you definitely want this. This is the most succinct way of expressing this concept. So will the optimizer realize that you can do this? Maybe not. I don't know. Does it allow to have fields instead of enum variants? No, because enums are just tags in Zig, and what you call enums with variants, like with fields, enums with fields, we call a union. So enum is just the tags, and then if something that has values would be a union, and then for simplicity, let's say that it's a tagged union, and then here you can do this. You can say who, and then this is going to be a U size and bar, and this is going to be a bool, and buzz, and this is backs or whatever, and this is going to be like a struct, and you put stuff in the struct. So the functionality is there, but the nomenclature is different. And I would be careful. I know that Rust does this, but I would be careful with considering enums something that has a payload, because in, I believe, pretty much every other language, enums are not something that holds values. Unions are things that hold values. And then your union can be tagged or not tagged. So in Zig, you can have a union that contains inside of itself also the tag, so that you can ask it what is the active case. And there's also unions that are not tagged. So you save the memory from the tag, but then you need to use external data, external information from another context to know what is the active case. Usually you do that because you already have information about the tag somewhere else. And so you don't want to have these redundant in two places. And what's funny is that when you build in debug mode, even a union that should not have a tag will have a tag. So the compiler secretly gives it a tag, and then it will panic if you try to access the wrong field. So you, in any case, you do have safety in debug and release safe. But then you release fast, you get the performance gains. Okay, what were we doing? Right, we were looking at all the calls to syntax error and deciding what kind of syntax error we were looking at. So what do we call this? The fact is that there is a different token, and maybe we should say what the token is, but maybe it's not necessary. So this could be .r. So we were looking for an identifier, and we found something that is not an identifier. Like not identifier. We can do this. Like we were expecting an identifier here. Does it have exhausting pattern matching on tagged unions? Yes, it does. I mean, you're looking at it here. If I were to comment this stuff out, well, I have other compile errors right now because I'm refactoring. But if I were to comment out one of these cases, then Zig would complain. Let's see. So this seems fine. So here we are looking at an extend path. We see a dot, but then we see that ID talk, identifier talk is null. So there is no next token. There is no subsequent token, or the subsequent token is not an identifier. So we can say error not identifier in this case too, I think. In both cases, we're looking for an identifier. Now we see a left parenthesis, and then we say, okay, the left parenthesis requires us to be in a path that starts at global or be in a dotted path. Something like this, not function maybe. I would say not callable. Maybe not callable would be the right thing to do. By the way, I need to actually create these guys. So not callable, not identifier. We see a comma where I call depth 0. You can comment time answer to errors at the end. Yeah, but it's fine. I don't want to. How do you have such understanding of good understanding of programming? You do it. You do it for long enough, and you learn something in theory if you do it the right way. And you know, there's people that have been doing for longer than me, or let's say in any case, like more effectively than me, who also know more about programming. You know, also what helps with knowing about programming. Like also maybe making a programming language, but not necessarily a serious one. I mean, obviously making a serious one will teach you a lot of things. But it's also a lot of effort. And even making simple programming languages helps you understand a lot about programming. Because you see the problem from the other side, right? You're looking at the other side of the equation in a sense. You're not a user, you're somebody who makes the thing, right? So for example, imagine that the question is, how are you good at understanding how to navigate websites and how to deal with forms, for example? And sometimes maybe there is a form that doesn't work well, and so you, I don't know, disable JavaScript or like tweak some things, or you know how to fix maybe tiny mistakes because you know how it works. One thing that helps you a lot is to be the one that makes websites, because you see the equation, you see the other side of the equation. I think that's probably true of a lot of things. So there's a comma, but we're not in a function call. Outside call. Yeah, we're outside call, not callable. Outside call. So here's what's happening. We are in extend path. So we have done foo dot something dot. And so we say, okay, well, actually I haven't seen the dot yet, but here we see the dot. Do we change state? We don't change state if we see a dot. Right, because, okay, so here's how it is. We are at, for example, foo.bar. So we are up until here. So there can be in front of us nothing, because this is the whole expression. There can be an open parenthesis because there's a function call. There can be a dot because maybe we want to, foo bar buzz, but not add functions. So it's either parentheses dot, or there can be a comma if we are inside of a function call, because we could be inside of a function call and we're like, it's foo.buzz and then comma next argument. Okay, so we took care of that. So yeah, it's open parentheses, close parentheses, dot, and closing parentheses I think has the same problem. Roll back. Okay, so we don't deal with the error in here in any case. Okay, there's a comma. Yeah, outside call. There we go. And then else. So anything else is an error. Anything else is an error. I guess it could be error unexpected, because we basically saw a token that is a correct token, but in a context that makes no sense. Guess we'd have unexpected token, and this is invalid token. More than this is error invalid token. Yeah. Unexpected token. Okay, we're in call begin. Else unreachable. Who? Let's see. We are looking at the call argument. You see a dollar sign. We see a right parenthesis. We can see an identifier. The identifier could either be an actual identifier or true or false. If we see an identifier basically without a dollar in front of it, or like a path that leads to it, then it has to be true or false, because we call them, so the tokenizer parses true and false as identifiers, as like native identifiers. And then we in the parser recognize these guys as, well, true and false. And we make them true and false nodes. So if it's something else, then this is a unexpected token, I guess. Maybe we can be more precise. I don't know in the future, but for now, let's say just unexpected token. String, extend call, blah, blah, blah. Okay, so let's see what's happening. So we can find a $sign something. We could be at the end of the call. So we see a right parenthesis, and then it means that this list of arguments has concluded. If there's an identifier, it has to be like true or false. There can be a string, there can be a number. If there's something else, yeah, it's unexpected token. There we go. Then extend call. So we got one argument. What can be after one argument in a function call? A comma for the next argument, or a right parentheses because we are at the end of the function call. If there's anything else, unexpected token. Call end. If there is a, we get into this call end state, but I guess this is not error, not outside call. This is what it was. After call, there can be a dot. Then it has to be followed by an identifier. I'm not sure this should be talk.lock. I think this should be after the token. This should be ID talk. Because the dot is fine. It's what after that is a problem. I'm going to change also what's up there. Okay, I think we're pretty much good. Here there's a syntax error. If call depth greater than 0 and not in terminal state, then, okay, so this is the case where we are saying error dot. It's like a truncated expression. Basically, there's something that it's not close, like truncated, I guess. Okay, let's add truncated. And in the other case where we're doing dot and then expecting an identifier, we do ID talk. Yeah, let's complain about this thing, not the dot itself. See if there's any other dots that need our help. No, I think we're good. Okay, we have made changes. Nothing crazy. Should be fine. I think we can even just do zig test source. We are in source. Parser.zig. Expected arguments found 159. Oh, what's happening next? In terminal state. How can we be in terminal state? Let's see. Oh, I think this is the truncated stuff, right? This is if we are at the end and we are not in terminal state, so we have not completed everything, and then you want more. Yeah. This is our truncated. Optional type tokenizer token does not support field access. Oh, there we go. Here's why I wasn't using this information, I guess. Error not identifier, ID talk. But the problem is that ID talk could be null. So this is a or else. And then we need to basically come up with a location that represents the end of everything. I think we have it. It's in these cases. Why am I using code underscore len and not? What is going on? Oh, I'm int casting it. Well, you know what? This is convenient, so I'm gonna put it here. Just convenient to have, I guess. There we go. Oh, you know what? Putting it up there makes it confusing to know where we are actually using this because we only need it down here apparently. So I'm instead going to paste this in the locations where it's needed. So here, no, where is it? Here. And we do the same in the other one. Oh. Oh man. All right. This is just else at that point. What's the next problem, man? Person tag has no member named R254. Syntax error. Oh, because it's not dot, it's here you passed in. There we go. Okay, so we passed all tests. We haven't broken any functionality. Obviously, there's now the problem that the VM right now has some things that it doesn't handle because previously it was handling like just a case where something was returning an error, and now returning an error is more complicated than before. So let's see. Yeah, previously we were looking at syntax error, and if it was a syntax error, we were doing something. Now this has to be different. So basically, yeah, the way I would do this is probably deal with it with an if, maybe. We could actually list here. You know what? Maybe the right way of doing it is listing here all the missing things. We can actually see this in action. ZBL is gonna error out. Not going to error out. How are you not going to error out? Oh, it's because not ZBL test. Yeah, there we go. No field name syntax error. So let's do this. Programming compile errors. Watch. Oh, you know what? Actually, let's use Zig1. Mlag implemented new watch. Let's watch it. Let's watch it in action. No field name syntax error. Okay. Watch me change this to R. Um, Invalid token. Yep. And this tells me all the other unhandled cases. Unexpected token missing dollar, blah, blah, blah. So you can actually do this. That's it. And at runtime, this is just syntax error. But we could be better than this. We could be better than this. We could give a string. Do we put that in the enum? Yeah, look what we can do. So here's what we can do. Pub function error message. We switch T. And we basically deal with only these cases. And we can do this. Else unreachable. Here you go, error message. So error here becomes no.tag.error message. Okay, so with this, we have got everything back into working condition. We haven't changed logic much. We just have more granularity in what we report. So this is good. And this is actually a decent stopping point for this stuff. Now we have a parser that tells us a little bit more about what it doesn't like of the syntax. And the thing is, we do want to wire this into the virtual machine because we would like the virtual machine to also be able to, well, to error out if needed and give you a nicer message than just syntax error. But we, as I was saying, we want this to get into the LSP. So how does this work? The LSP, well, I guess this works like this. We need to go into Super HTML. And then we need to see how Super HTML deals with what's in the Super HTML AST. In the Super HTML AST, we parse the Super HTML AST. There is here a list of errors. And the errors are, let's see, bad attribute. So these are errors specific to usage in the AST. Then there's duplicate block that has some extra context. I think here we need another thing. We need a scripty syntax error. We want to take scripty. We want to basically parse it. And I think what we want to do is throw away what we parse. So we parse it once, And then we don't keep this information anywhere. We just keep the errors nodes. If we encounter an error node, then that's what we save in here. Like we make an error for this, and then that's where we stop. You know what? This is nice because it actually doesn't require us to do much to make this work, I believe. So here's what I'm thinking. I'm actually gonna extend this and push downward the Radix tree work. Let's get this to work. I want to see this working, and I think it's actually not that complicated. It's making me think that I was actually kind of a dummy to not have done this earlier. So here's what I'm gonna do. I'm gonna take a very short break. I'm just gonna go to the bathroom very quickly. Then when I come back, we do this. Basically, we add this scripty. This is just a scripty error, and it's gonna contain something like scripty. I don't know. It will contain the extra information that we put in our errors, and yeah, it's probably gonna be a scripty dot parser dot node. I think we keep around the parser node, and yeah, okay, this is gonna be cool. Oh yeah. I'll be right back. Okay, I'm back. Okay, so we want in our Super HTML thing to also have the possibility of having scripty errors. So we have scripty around here. Interesting that we don't import it in here. I guess it's in the VM that we care about scripty more than anything else, but now we care about scripty also in here. That is, actually, this is nice. This is like telling that this is what's going on. Also, I'm going to take this as an opportunity to reorder things in the way that I like it now. I like this. And you know what? Maybe I'll put scripty after building. Okay, so we have scripty. So this is going to be a scripty error, and it will contain a parser node of scripty. Now, we have this extra possibility, which is great. The next thing that we need to do is, produce one of these errors. So where do we produce one of these errors? The answer is whenever we see that something is a scripty expression, and we do check for this stuff as we parse. We do check for this stuff in we do this in build node, I suspect, but I'm not sure. You know what? I think this is what we do. Start with, yeah, look at this. Starts with is what we used to say, oh yeah, look, we found an attribute and this attribute is scripted. And so that means that this is going to be something scripted. So this is certainly one. Has attribute scripted. And then we say, if it is an ID and we think it's a block, then we complain because this is a block with a scripted ID, and that's really bad. And that makes sense. Then I would say after this, we say we validate the script expression. So I would say, I think there should be a method on the parser, p.validate scripty. And we pass in what? We pass in code. We need extra context though. We need to pass in, maybe we can pass in down the value. Do we pass in the code like this? No, we it depends on how we want this thing to work. I think they're giving it an attribute value. What is an attribute value? Quote, a span. What is an attribute? Name, span, value. It's a span and a quote. Method to get a span from the whole thing. To be honest, we are actually fine with just a span. We don't even care about the outer quote. Although, does the span include the quote? I think the answer is that no, it should not include the quote. We have an escape. We're going to look into that, I guess, at some point. For now, it's fine. So validate scripty. A little span, maybe. Okay, so now we have to make validate scripty. Okay, validate scripty. How does it work? So code is utter value dot slice. We have also p dot source. Then we say transcode. Then we say we need to have a scripty parser. And I'm guessing the parser is what drives the tokenizer normally. Then we do the parsing. We keep throwing away nodes until either we end or we find an error node. And that's what we care about. There's no init. So you, what? It only has a next? Oh, okay. Holy shit, this thing is very bare bones. So never mind. That is absolutely untrue. You do not control shit. You, let's see, parser. New code p.next case. Oh, but these guys have default values. Oh, that is delightful. Okay, so you make a parser without init. So like this. And then you keep calling next on it. So while scripty parser dot next code. Node.tag is error. Well, actually, wait a second, because we have. Yeah, it's node.tag.is error. All right, the reason why we don't see this is because we haven't updated yet. I guess I can do this. Zig is on. Yeah, there we go. It sees it. So if the node tag is error, then we do try p dot errors dot append p dot gpa, I guess, and then we append the error. And the error for us is dot scripty, and the value is going to be the node, but this is where things become problematic. The problem is this. The location in our file where this error occurred is not what scripty thinks it is. It's an offset based on where the actual original value was. So we need to say, take what scripty says and add the offset at which this guy starts. So this value as a start, and we need to add that. So dot tag equals node dot tag, and then I think it's lock. Oh, okay. We have to remake this node and turn it into, give it the proper offsets, I think. Maybe we could even change the type of location that we use. To be honest, we could make our own type for this stuff. Well, in any case, so far so good. Now we have a bunch of problems though, because this stuff does not build. This is guaranteed that it does not build. Is absolutely guaranteed it does not build because we now need to check a bunch of other things. Let's do zig1, print compilers, watch, yeah. No field name JPA in AST.parser. Oh, it doesn't hold a GPA. Am I really passing around GPA manually? I guess. Oh, I don't even have allocator. Oh god. Nothing named scripty in ast.error. Oh, kind. And then main location. Oh, there we go. Okay, so scripty, this is no dot tag. There we go. So we already had this distinction. Perfect. Okay, so we do this. So we already have this. So this is kind. Kind is scripty. And it just contains the node tag. And then we have main location. And it's a span, not a lock. But okay, span is this same concept. Okay, so we are doing it right, actually. And I don't know, this goes away? How does it work? I think we did it. Okay, so this should be fine now. Let's see, no field name start in start parser node. Right, because it's node dot lock dot start. Okay, with this we have everything in, but I bet you that this should fail to build the CLI. So here we're running test, but without test we're building the CLI, and I expect this to fail because we don't know how to print that error. Really? That's kind of sad. It means that we have some code that deals with these guys and that doesn't care about scripty being what it is. Could be worse, I guess, but in any case, so how do we do this? We have some kind of error FMT code somewhere. Have errors.zig, but that's a different thing. Diagnostic. Yeah, no. Okay, let's keep scrolling here. validate, print interface, print errors. There we go. Path, and we just print error.kind. Really? Okay, so I guess, you know what? This is, I guess, fine. Let's, well, no, this is not really fine because this could be better. Come on, man. Arrow.kind. You know what? Maybe we should give a format to arrow.kind, and that is the solution. Let's change this to be like this. So this is an F now. We expect arrow.kind to have a formatting function. So let's give it to it. Pub function format t tag. Actually, I should say it should be k-kind. I don't know. This and w pointer to writer, and this is it. And so what do we do in here? We switch over k, and for everybody we do try writer.print t k, but for scripty we do try w.print s, and then we do s.error message. And I think this should work. Then, so we have this formatting, which I think it's better. It's good to have. Then we have the LSP, but the LSP has, I think, its own logic for printing these errors, or at least some of it. So I guess it's time to see what's the state of our LSP stuff. I think somewhere we have a big branch, like a big switch for our errors. Maybe I'm too optimistic. Is logic this empty? Holy shit. Document is also empty, so it's either LSP or nothing. Do I really not do that? Formatting on response, formatting did close, did change. So here we send a notification in case there are errors, right? Content changes, and we do load file. And load file is the one that sees errors. Let's see. First HTML errors, and then if we are in super AST mode, it does super AST errors. It does get range on messages tag name error.kind. Messages tag name error.kind. You know what? I think that we can do even better. So we have this format that does this, but I guess we can do this. So instead of, yeah, oh man, we can do so much better. Pub function message, and then we do k colon at this, and this returns a const u8, and we do this kinda. Well, basically we do this. This is return, and in this case we do at tag name k. In case of scripty, we do s.error message, and we don't even need format. And then here we don't branch, and we do try w.print k.message. There you go. So in here, instead of doing this, we do error.kind.message. I think this is actually it. Well, once we actually compile. Yo, what theme do you use? My theme is One Dark. I think we have it. I think we might have it. Or not. Where's my LSP? Did it crash? We have Super HTML. I think we can check. No complaint. Come on, dude. Oh, I think I know what's happening here. I need to wire it to more things. Like, for example, can I do this? I think I need to wire this reporting stuff to more stuff. Let's see. In here in AST, so we're checking here for code, and we do this. More than this. Then here we are checking for this stuff. So in validate, we're saying element with an unscripted ID cannot be directly under a loop. As I guarantee, okay. So what's happening if okay, so we're not building anything? So this is the only place where we check for script expressions. No, this is when it's a normal attribute that has it. But then there's special attribute, and special attributes always have a scripted something. So this is where we do this. We always need to validate a special attribute. Hello. Yeah, I did take a look. Sorry, I got dragged into this improvement, and I want to make to my LSP for HTML because I got so close to make it actually work. I actually forgot that it was this easy to introduce this functionality. For some reason, I thought it would be much harder. Instead, it's very trivial. In any case, let's see. Increase control back about the placement of the length field, and I think it's only possible with the distinction between struct and tail. Having the tail designated just gives you more guarantees when doing content reflection. Mm-hmm. Yeah, I need to take a look again. Sorry, right now my brain is entirely into this parser stuff. But I'm almost done actually, so it should be nice. This is utter.value. And actually we don't know if the value is there, but the value should be there. Do we check? Else with value. Oh yeah. About else. Let's forget about else for a moment. What about the other ones? Oh, there we go. So here we deal with the attribute. Here we're saying if the attribute is null, then we complain. Let's turn this into this. Okay. I think that this is what we were missing. Oh, what are we doing with code? Unscripted attribute. Oh, I see how this is going. So maybe we don't do this here. We'll do it here. So if we know that everything is fine, hmm. Oh no, I spawned like 1,000 builds in the meantime as I was touching this file. I am not sure what is the right way of doing this. This code is kinda... This code is a little bit whack. But for the sake of... For the sake of completeness... Missing attribute value. My mouse is not working anymore. Computer is dying. Oh no. Oh, there we go. Okay, now we're back in business. Missing attribute value, unscripted attribute. I think this unscripted attribute case should be... We should not do this. And instead we should do this. I don't think we use code downwards, right? Yeah, we know because it's unused. Oh man, this is delightful. Like, I know that this is unused, so I can take it out right away. And I can do this instead. I give these curlies. And I have nothing to break. We actually don't even do this. And this is where we do the validation. Try p dot validate scripty GPA v. There we go. Okay, that is the right place. What's the problem? V dot span. Okay, I think we might have it. Server language exited. Okay, so no, we got a crash in the language server. You saw that the moment I edited something, the language server immediately crashed. And I think it might be, let's see, let's try to have something else in, yeah, look. So other errors are being reported, but let me open a tail. Let's see the Helix log. Let's see what happens. Although broken pipe. Let's open another tail. No such file or directory. Okay. Let's take a look what happens now if I make this crash. Did it crash? I think it already crashed. What happened? Oh, let's see. Page. It has crashed already, but we don't see why in the... What the heck? Hmm. Well, you know what we can do, I think? Maybe we can do this. Still does not complain. But if I put this here, oh, it does not complain either. That is bad. Although, no, actually, this might not be bad. I think this is the problem. It's, yeah, it's the open stuff, not the closed. So we are working something with regards to how we deal with this. With this, for example. We're definitely working something. Oh, and you know what it is, I think? Let me see. So what could we possibly do that causes terrible misfortune here? Honestly, I wouldn't know because um, previously we were doing at tag name. Now we're showing a message, so it should not be this bad. This editor right now is having all kinds of issues. Cat, layouts, page.html. I don't see extra logs. This is bad. Maybe I should invoke Helix in more verbose mode, but what about Super HTML? I expected Super HTML to be more verbose in a debug build, which is what I have right now. Let me see how my verbosity level works normally. So let's look at the LSP main function. How do we do this stuff? Actually, you know what? We don't do it here. We do it in our main function, in our CLI. So log level. Let's see, panic. Blah blah blah. Command. Let's see. If the command is LSP, then we set LSP mode to true. And LSP mode dictates how we print panics and where we log. If not LSP mode, then everything goes to stdr. Otherwise, everything goes to the log file. And the log file is initialized. It's initialized here in main. Or maybe not. Maybe it's like some setup function that we call. Yeah, login.setup. Oh, it's super html.log. Yeah, which is what we have here. Okay, there we go. Now there's more info from Helix. Here we're not printing anything still. Language server exited. But we don't see anything here. I think we are failing to log somehow. So we don't know what causes the crash. We don't know what is causing the crash. Okay, so here's what we can try. Let's try login to STR no matter what, and let's hope that let's hope. Also, LSP mode. Okay, let's comment this out, see what happens. Rebuilding an LSP for Super HTML. I already have one. I'm making it better. Also, do I have some weird flag that I enabled for extra logging? Like a D-log? Verbose logging. Also in release modes. Okay, so we do have enable this scope. All scopes are enabled when none is specified through this option. Can be used multiple times. Okay, we got something from Zig. Let's see. Now we see the stack tracing here, which is kind of a messy. Reached unreachable code. No, bunch of question marks. We don't have debug info, but we do have it in Zig1. Let me make a Zig1 build. Okay. We are making progress. Wait, where's the backtrace? Oh. Oh, okay, no, this is another issue. There we go. Oh no, we still don't have we have something but not a ton. The fuck is going on here? So error parser.next invalidate scripty parser.next we reach a reachable code. In parser.next we reached unreachable code. Huh. Actually, let's use this one. Somehow we reach an unreachable code. Oh, I know what it is. I think this is a silly mistake on my part. So yeah, you see how we see that there's an error and then we do some setup. When this happens, we need to return. That's me. We forgot that we need to return when this happens. Here, actually, to be precise. We append this error and then we call it a day. You don't invoke the parser again after the first error. Okay, this things should be better now. There we go. Unexpected token. And then look if you try to call a function. This is not callable. Perfect. Missing $sign. There you go. Unexpected token, but then you put a dot and it's fine. Then you put a trailing dot and it says, I'm expecting an identifier after this. Oh, this error is a little bit confusing, but yeah, unexpected token. That works. So we did it. It is genuinely working. This is nice. You know what also would be nice? It would be nice if we had syntax highlighting for scripty expressions. That would also be cool. I think it is another thing that we want to try to achieve. But for now, I think we can kind of push what we have for now, right now. So what did we change? Because a bunch of things changed. So we have a bunch of new syntax errors. We have code for printing them. We moved tokenizer old somewhere else. The VM now prints better errors. Okay, its status. Oh, remove source/labels. Remove source/while. There we go. Yeah, this will help tooling report errors in scripty syntax. Oh, there we go. That's it. That's literally all there is to it. So then in Super HTML, we want to do this. Oh, let's see if the CLI also does it correctly. Yeah, there we go. Oh, what if this is multi-line? And there's a dot. Okay, it actually detects multiple lines correctly. It is delightful. So Super HTML will now be able to report syntax errors in scripty expressions, both in check, both in CLI mode and LSP mode. There you go. Git push, but I don't think we can depend on this from inside the zine yet. But in any case, these are all things good on their own. I think I should inform people about this. Uh, okay. Um, we have it. This was actually surprisingly easy. Why haven't I done this earlier? Well, what is the next step? So the next step is, I think, even more interesting. The idea is, well, okay, now we can validate the syntax, delightful. But can we validate that the things that we're doing in there make sense? And that is much more interesting. But it requires something more. It requires more knowledge. It requires the knowledge that only Zine has, which is what even is the evaluation context. We need to know what the evaluation context is, or Zine would need to output it like as a hidden file. In Super HTML, we need to be able to pick that up and analyze it. Well, this is information that can be serialized, I think. Hmm. Yeah, it's something like this. But I'm not gonna tackle this today. Okay, so I think I don't have a lot of time left because I need to leave like in half an hour. But we can spend a little bit of time to flesh out the Flex implementation and add a couple things that were missing from it. So let's take a look at what we have so far, and let's think about what was missing, and maybe we can start adding this stuff. And you know what? I think we can do this with a failing test. So let's make a failing test for this. Actually, are we succeeding tests right now? Are we winning tests? We win tests. Okay, let's make one that we fail test. Um, I think the idea is this basically. Who, and it contains I don't know, bar, which is a usize, then contains box buzz length type. Length type we don't care. We actually have it default to usize. Yeah, let's make it default to usize. And then here we want to say this. This is not a U8. This is a usize. And these guys have alignment. And then we put bytes after that. And this is like test alignment. And we need to use it. Something like this. We create a foo. And here we have buzz equals 1. Does alignment help save memory or what? Ooh, it's a little bit more complicated than that. You can specify alignment on field of struct, so flexible array can read it while iterating. When you say field of, you mean here? Or do you mean somewhere else? Can you show me some syntax of what you mean precisely? What's the first argument in flexible array? Yes, it's the type of this field. Like this is a list of bytes. This is a list of view sizes, for example. And you know what? This should not contain a usize. This needs to contain a... can you have a flexible array or a flexible array? To be honest, I don't know what happens if you do that type of stuff at that point. No idea. I think it would work. No. I don't think it would work. I think it would bork all the math. So we don't want to do this. I think... we make this a U32. Let's see what happens. Okay, we do that. And we need to set the values, I guess, with init. What is it that we have down here? Oh no, this is gonna have all kinds of casting problems. Expected type constituent found slice of U64. Fair. Root error. Pointer cast increases point alignment. There we go. This is nice because this is being basically caught by the type system that we're doing something sus. So here we need to do an align cast. And I think we are going to fail the align cast at runtime until we do extra math. It's not in create. It's in slice. Here. We need to align cast. And really? Success? I think I was unable to make a compelling test then. Because I think we should be failing this. No, maybe I'm dumb. Maybe this should be like this. I think this is how it should be. Hell yeah. Watch it explode now. Oh, well, first I need to fix this. There we go. While executing tests, the following command terminated with signal 6 expected, exited with execute 0. So we can run this. And we can see this. We are failing the alignment test. Okay, now we need to do alignment math. So how does this work? Var last flex. It's a optional last flex align, I think. We don't have to worry about the alignment of this guy because we don't care. But let's say last flex align is of type no, mem. Where do we have alignment? Oh, we have it in mem. Okay, let's say that it's type of mem alignment. And it's optional, maybe? No, we default to 1, I guess. Right. We assume that any alignment is fine as a starting point. And we find one of these guys. It is not us. So when we increase the offset, we multiply the length, the size. We multiply the size when we do this. But we also need to align forward first. Except if one of these slices is 0, like doesn't have any element, we don't want to keep empty bytes for alignment. So I would say that the alignment factors in only if length is greater than 0. So I would do it like this. If value.len is 0, then well, let's say it's different than 0. Only then we do this. And previously it was fine because, you know, len being 0 turns this basically into a no-op. But now it's different. And then we do offset. And then we do basically... Oh, crap. Because we want to align forward, right? So offset is not an offset anymore. So I guess we can turn offset into a pointer instead of being this. Also, I'm not sure that we need last flex align. I think I'm being dumb. But we need to change offset, I think, to a pointer. Because the point is I want to be able to call align forward. Actually, where is align forward? Is it in mem? I'm guessing that's where it lives. Align pointer offset returns the number of elements that, if added to the given pointer, align it to a multiple of the given quantity. Or null if one of the following conditions are met. Oof. Align pointer. Align forward any align. Round an address down to the next or current align address. Unlike align forward, alignment can be any positive number, not just the power of 2. Yeah, basically we want to be able to use align forward. We want to be able to use align forward. I guess we can kind of fake it in a sense. We could say, well, yes, we want to do this. Offset equals int from pointer of std mem align forward of yeah, I know the use of this already, Tristan. I just want to think this stuff through myself. So actually, you know what? I will take a look though. Maybe you have a different approach. That like I don't want help with the math. I want to figure it out myself. But let's see. You have offset of okay. Line 4 struct fields. Meta lines forward. Oh, you can do U size. Oh fuck! I didn't know you could do that. Okay, so then that makes it easier. Okay, so well, I think that's the part that helps me the most. So if I can do this without going insane, then it's just this, right? Align forward. U size. The address is offset, and then the alignment is align of t. So let me see, because I might be doing something dumb. We are past the end of the struct, and we are about to see the first flexible array, and we want to jump past it to its end. But what is its end? Its end is how big it is, and then any padding that it might need before to fulfill its alignment. To fulfill its alignment. And so here we say, well, if there is anything that we should worry about, then it's going to be, yes, that's how big it is. And this is how much we need to align forward for it. Now, this all seems fine, but the problem is What if this field was us? If the field is us, we're not doing this properly. Because if the field is us, then we actually need to provide a pointer. Do we not? Oh, you know also what is interesting is when a field has length 0. Like length 0 is problematic because when a field has length 0, then what pointer am I going to return? Because if the assumption is that I don't want to allocate memory for alignment padding if you don't have any element, which was my assumption, which is why I'm doing this if right here. The problem is that if we don't do that, then when we try to get a slice of an empty thing, we're gonna try to return a slice with a pointer that has the wrong alignment. And in reality, it shouldn't matter what pointer we return because the slice should be length 0. But then we also have the ones where we return a pointer too many. And that one, that one definitely needs to have the right alignment. We're gonna trip zig safety basically. We're doing bad things. So that probably means that even if the slice is empty, we always need to allocate memory for the alignment. And I would say that it's probably fine because not putting this stuff there is, I don't know. It is an optimization, but not a huge one. Because the alternative is that we recognize the case and then we return a bogus pointer. But generally speaking, it's not nice to return bogus pointers. You can do it, but it's not great. Okay, so let's assume that we don't do this always like this. Also, I think it's like this. And also, I think that this has to happen before. So we need to do this, right? We compute the offset right away. Sorry, we increase the offset right away. We take current offset, we align it forward to type T every single time immediately. Then we look if it's us or not. And if it's not us, then we also increase it this way. Okay, this is sound. I think this makes sense. Now we only need to do align forward also when creating. So I think that if we do this, then we should do better in the test, but we should still poop. Oh, we don't poop. This test did not fail, but I think that we are reading out of bounds and we don't realize that. Sorry, not just reading, but also writing out of bounds. And I think we don't realize that. So when we create, what do we do? Here, for each field, we're basically doing the size. But we also need to do this. So we size for P, size of P, and then for each field, if it's a flexible field, we need to do something like this, right? We take size. And then we align it forward. And we align it forward for type field.type. I think that's how it has to be. And then here we set values. No. Invalid free. Because we do the math wrong in destroy. Ba-da-ba-ba-da-bum. There we go. Now we're back working, and I think we are not reading out of bounds anymore. Okay. So we have alignment support. This is good. The next step. Hello, Jim. By the way, check this out. We are reinventing flexible arrays, but in Zig. And this is like design one of N that exists out there. So this, if you haven't followed, this is an interesting discussion happening on Zigit, where Tristan Pemble, who is here in chat, he's Rever B Addict. Oh, Reverb Addict. I got there at some point. Yeah, Reverb Addict. So this is what he made. It's kind of like flexible arrays, but also not. So he made a design that is very different. So here the example is that you have a connection, and where is it? Yeah, here's the his implementation. So you have a connection, and it has some. You want to do the thing where you allocate one chunk of memory that has like a header and then a bunch of tailing data that you want to keep all in one allocation. So you could put these as slices on the heap and then have the struct contain pointers to them. But it's more efficient sometimes to squish everything together. And in his case, what he's doing is an interesting in-between that I have never seen before, where the idea is that you put some of the struct on the heap, but then the length of these individual like tail sections, you keep in this structure that he started calling structured slice. It's like a slice, but the slice has, one pointer and then multiple lengths. And this is curious. The approach that I'm using is more similar to what C would do, which is these lengths go on the heap in the chunk, because this is like a return type that you basically deal with. Like it's a slice basically, just with more fields, and so you don't have all the information in the contiguous allocation. Well, in my case, I'm putting everything into the contiguous allocation. Yes, you just cast the byte buffer. But what is more important is having type safe and type safe access to those tailing to those fields, right? To the tails. So this is my approach. My approach is here I'm actually, by the way, I want to then use this approach. This is what I'm making, and see if I can re-implement a Radix 3 from C to Zig and see if it's any better. And so my approach is instead, well, this approach started by Andrew Revsky here in chat, and I'm fleshing it out. And basically the idea is here we heap allocate all of these. Actually, so this is the definition. You define your struct, which can also be a packed struct, because usually when you're making like a fancy data structure, you do want this to be a packed struct so that you can be precise with sizes of things. And in this case, you can see that the header is, well, actually you can't see this because oh no, you can. Okay, so here's how it works. Here the header has one Boolean. This is 1 byte, one bit. Then another Boolean, second bit. And then another third bit, and then 29. So the header is basically 32-bit. That's it, yeah, I guess. Yeah. Have a nice day. Okay. Yeah, I have never seen that approach that you took. That was completely a surprise to me. Never ever. So I actually would be curious to see, one concrete use case where this is like shining, where it really shines. And I guess the network version, the network thing would be one of those, I guess. Yeah. In any case, this one is the one that I'm more familiar with, the Radix 3 node. So let's see. Okay, so we have alignment. The next is going to be implementing copying. And by the way, still thinking about the Radix 3 example, what I am thinking is how would it work to support super linear growth reallocation patterns for these guys? Because we are dealing with slices, and maybe you don't need this every single time, but I do think that sometimes super linear growth would be interesting. And maybe this can be offered by the data structure. Maybe it does not get offered by the data structure, and you manage it manually outside. Wait, but how past flexible array would get its length? What are you talking about, Andrew? I need more context. Last flexible array gets its length in destroy. Oh, in destroy, you have to pass it in. When you destroy, because this information is not known, like the whole point of having a void flexible array is that you do not store the information in there, right? Because you know you can derive it from some other piece of data. So when you call destroy, you have to pass it in. If the struct has a flexible array field that has a length type, then set to void, you must provide its length. Pass a null otherwise. And this is actually not the greatest API, because if you think about it, we're generic with regards to the type. So in practice, where is that length? It depends on your scheme. In for example, in the case of Rax, it would work this way. In the case of Rax, you have two layouts. This one where you have, this is a string. So this is an array of bytes. X, Y, and Z are 3 characters. And then you have one pointer for each, right? So the length of this guy is the length of this guy. So we don't store the length of this guy because we know we can derive it from this guy. But then there's a second layout. And it's the same data structure, but if you flip a Boolean, whether the node is compressed or not, then you switch from one layout to the other. And obviously you have to update also the rest of the memory and keep everything consistent. But in this scheme, then another layout is you have a slice of bytes, and then you have one pointer, only one. So what does this mean? This means that in this case, the way I guess we would code this is this. Let's say that we're doing free of Rax node. Free of Rax node would be this. So let's say const r is a pointer to Rax node, and then you do destroy GPA whatever, and then you pass in r, and then you have to pass void len. And so here you would do this. You switch r.layout. And then in the merge case, this is the equivalent of compressed from the original code. I just call it layout. So if it's merge, then you know that there's one at the end. If it's split, then you know that it's r.bytes.len. And this is one example, right? But the point is that it could be anything. Like the point is you don't store the information, and then however you derive it, whatever is your scheme, it's managed by you outside. Bytes and pointers in your implementation are not going to both be filled at the same time. No, they are. So it's like this. You basically you have this. You either have this. Let me see the definition. I'm gonna do this up here, so it's we're closer to the definition. So it's like this. It's either dot layout equals dot merge, and then that means that dot bytes is equal to, I don't know, like 10. And then implicitly, because you can't put this in here, dot ptrs equals to 1. And so, or let me put it this way. Let's use pseudocode, like fantasy syntax. You obviously, these are the actual field in the struct will be just the length or void. But let's imagine that we can put there the actual content. So this would be this, like ABC, and then pointers would be ampersand next node. And then the other case will be this. X, Y, Z. And this is going to be Z node. Sorry, that would be X node. X node, Y node, Z node. So you get the idea. So you initialize this node into one type or the other, and then sometimes you switch their kind based on all the operations. Let's see. Can't you infer at comp time? Should you use pass void or not? Yes. So destroy, since we are generic with regards to the type of this guy, we could do better. Yes, we could totally do better than my current API. Can't you remove child pointer and just inline the child? Yes and no. As in, conceptually, yes, if you design a different approach to radix trees. In the case of racks, no, because what happens is that usually the next, where am I? Usually when you have ABC, so imagine that this is like this. This is maybe CA, and this one is RT. And so you have R node and T node. And so the point is you can't really inline it, because the point is that this is representing you CA, and then you have to choose between R and T. So it's car and cat. And then cat might become caterpillar afterwards. So in the way the racks works, you have two different nodes. You have a merge node and I got this wrong. This needs to be split. I forgot to change this value. And this one has a different layout. So the way Radix works, you can't. But it's how Radix is designed. So if you want to design something different, you can. So long story short, no, you do fill both at the same time. But pointers sometimes is known to be just one pointer. When layout is merge, this is just one pointer. And you know that for a fact. When this is split, the length of this thing matches the length of this thing. Are the byte buffers in the Radix node padded out to 8 bytes, assuming 64-bit systems? Otherwise, the array of pointers that follow will not be aligned on 8-byte boundaries. The answer is, yeah, when we allocate stuff, we do alignment math. So every time we create something, we look at how far we are. And then when we need to go to the next item, we know that we need to align forward. And there will be some padding data between the slices depending on the types. So yeah, I just added alignment support right now. Why not always prepare a split node to merge node? I don't know. Maybe that could be a cool way of doing a Radix node. There are probably reasons why this is implemented. Okay, I think you should expect this implementation to be reasonably clever. So there are probably reasons why things are done this way. in the way that Anti-Res designed it. That said, it is probably true that this is not the cleverest possible way of doing a Radix 3. There are, for example, Radix 3 implementations that consider SIMD size when allocating nodes. And so because they use SIMD instructions to compare the string that you're comparing against what's currently in the node. And so because of that, they tend to size everything based on SIMD. This implementation is not aware of SIMD at all. So for example, that's a big piece of like smart functionality that the original design doesn't concern itself with. But the SIMD version obviously has, littered everywhere SIMD concerns that you might not want, that make everything more complicated to understand. So I don't know, trade-offs, such is life. So I think this is it for me. I think okay, let me return to a working condition. No, actually we do need this. Let me see if we pass tests, and then I'm going to commit its status. We basically added alignment support more than anything else. Okay, so I think that in next stream, so now that I'm happy with the scripty parser stuff, the next stream I'm probably going to focus more on this, and we're actually going to start trying to make this work for Rax. That said, I still have in the back of my mind, so on one end, having SIMD support for this type of data structure is good. And I wonder how, not annoying we can make it trying to use some SIMD. And then the second question is, can we have super linear growth of nodes, allocation strategies for nodes, so that we can, not pay allocation price every single time we resize a node, because that is horrible. And I think it's possible, but obviously it requires a concept of capacity versus size versus length, which we currently don't have. And I'm not sure it's worth it. In any case, trade-offs, right? So it's interesting. I'm gonna, in any case, I think start from the you know what? First of all, we need to test if we can actually comport the original code and make it good. So maybe let's start with the simple stuff, and then we can think about improvements afterwards. Okay, let me see if anybody is doing Zig, and then we can call it a day. What's happening in the stream? Oh wait, there's Toggle live. You know what? I'm gonna raid Toggle. He doesn't do Zig, but it's fine. Toggle. Enjoy Toggle.